Alright, we're talking about 4.1 today, which is graphing and inverse functions. So just a heads up about this chapter, this is perhaps one of the most difficult chapters for students to really grasp right away. So a couple of things is we're going to need to be focused and not distracted. So if you're going to do some questions, you got to focus on them. You got to be resilient. If you don't get it right away or you run into some setbacks, you just got to keep pounding it out, and I promise you it'll make sense and you will do great on the test. And lastly, when you come into these problems and when you start doing some, you have to intend to succeed. So when you start, you got to think right away, yep, I'm going to do awesome at this. So let's get started. So if you want to whip out your calculators, make sure you are in radian mode. So you're going to have to go into that mode, which is on the top row, and make sure it's in radians, not degrees. And in your y equals, type in sine of x. Go ahead and press graph and zoom trig, and you should come up with something that looks a little bit like this. This waving function here. Now this is the graph of sine of x. And a couple things we notice about it right away is that it looks like a wave. In fact, we say that it follows a wave action. You know, it's very smooth. It keeps following this wave action. And the second thing is that we can say is that it's periodic. And what we mean by periodic is that after a certain point, it repeats itself. So if you notice, if we start here and end here, and then we can copy-paste that piece that's in between the green lines and paste it on the positive x-axis, it looks exactly the same. And we'll dive a little bit deeper into what periodic means, but for now we just say that it's periodic, that after a certain point it starts to repeat. So let's walk through the steps of graphing y equals sine of x. And we're going to think back to our unit circle. So I would personally recommend drawing your unit circle on the side, because we're going to use this to graph sine of x. So if we think about x's as our radians, our input radians, what happens when we graph, when we look at 0 on the unit circle? Well, 0 on the unit circle is where we start. It's right there. Remember, sine of x is the y value of each point. What's the y value there? It's 0. What about pi over 2? Pi over 2 is straight up. On the unit circle, the y value there is 1. If we keep going to the right, we go to pi. Well, pi is straight left with a y value of 0. 3 pi over 2, that's straight down. That's a y value of negative 1. And if we think back to 2 pi, that's one full rotation around, and we're back at a y value of 0. So I'm going to plot each of these points. Well, at x equals 0, my y value is 0. At pi over 2, well, pi over 2 is 1. So we're up to 1 on pi over 2. At pi, we're at 0. At 3 pi over 2, my y value is negative 1. And then at 2 pi, I'm back at 0 again. Remember what it looked like when we graphed it. It's a smooth curve that looks like a wave. This is what we call one period of the sine x function. It's from 0 to 2 pi. And again, we'll dive a little bit deeper in that later. It's important to remember now that we can plot any point on the unit circle on this graph. So if we take pi over 4, if we think back to our special triangles, 45, 45, 90, I know I have 1, 1, square root, 2. So if we think about the sine of that, it's square root 2 over 2 when we rationalize. Well, square root 2 over 2 is about right there. So we get a point, pi over 4, square root 2 over 2. And if we notice, there's another point on this graph where it crosses square root 2 over 2. Well, that's 3 pi over 4. And if we think about our unit circle again, right, there are two triangles that I can make on my unit circle that will have a positive square root 2 over 2 for a sine of 45, or a sine of pi over 4. And that corresponds with what we just made on our graph. There are 2 points on my graph where the sine of my input is square root 2 over 2. Same thing with 5 pi over 4 and 7 pi over 4. That's going to be a negative square root 2 over 2. And again, that corresponds with my unit circle. There are two triangles that I can make on my unit circle where the sine of those reference angles are negative root 2 over 2. So if we want to head back to our calculator, again, make sure we're in radians and plug in y equals cosine of x. When we press enter or graph and trig and zoom trig, we get something that looks a heck of a lot like this. Again, it's very similar to what we saw in the sine of x. However, you'll notice that it's a different starting point. We start at 1 instead of 0. But again, we follow this wave action. So what do you notice about this? Well, again, it has a wave action. And just like y equals sine of x, you'll notice that after a certain point, it starts repeating, or it's periodic. So again, it follows a wave action as a smooth wave, and it repeats itself after a certain point. So these are what we found for the graphs of sine x and cosine x. Notice again we have what I said earlier, a period. Period is right now of 2 pi. That's the period of the parent sine and cosine functions, the originals. Well, what does that actually mean? All that means is that if I were to start at 0 and follow my curve along, after 2 pi, after a distance along the x-axis of 2 pi, it would start to repeat in either direction. So I can go in the negative or positive direction. But after a distance of 2 pi, it repeats. Same thing with my cosine graph. I follow it along, and after 2 pi, it would start to repeat in either direction. Well, then we see that it has this amplitude of 1. Notice that both of my graphs, the farthest up they go from the x-axis is 1, and the farthest down they go is a distance of 1. Amplitude simply means the factor that I'm stretching my graph up and down by. So if it's by 1, I'm not stretching it at all. If it had an amplitude of 2, I would multiply the height by 2. I'd stretch it by a factor of 2. And that's going to be what we're diving into tomorrow in the next lecture. So don't worry about that too much yet. So let's go and graph sine of x and cosine of x over 0 to 4 pi. Remember, I said on the last slide that the normal period is 2 pi for both of them. So you can assume now that we're going to be graphing 2 periods. From 0 to 4 pi, that's 2 pi's. And whenever we graph these, we always start by graphing 5 key points. Well, 4 really, because after the 5th one repeats the first one. So we take our period. Remember, our period is 2 pi, and we want to graph 4 key points that are equal distance away from each other. So we're going to divide it by 4. So our key points are going to be pi over 2 away from each other. And we always start at 0, x equals 0. And now at pi over 2 is going to be my first key point. My second key point is going to be another pi over 2, or pi. Then 3 pi over 2. And then 2 pi. And then again, after that, I'm going to do 4 more. Remember, I have to do 2 periods. Right now I have incremented out 1 period. So another pi over 2 gives me 5 pi over 2. And then I'm going to have 3 pi, 7 pi over 2, and then 4 pi. Notice, if we were to equate this back to the unit circle, well, 0 is just where we start. You'll notice my first key point is pi over 2, which is in fact straight up. Pi is to the left, 3 pi over 2 is straight down, and back to 2 pi. So really all I'm doing is I'm graphing out each of my points where I'm straight up, straight to the left, straight down, and so on. So if we think about, remember we're sine, so we're thinking about the y value of pi over 2. So we're going to graph at pi over 2. Remember, my y value there is 1, so I'm going to go up 1. We go to pi. Pi is straight left with a y value of 0, so we place it 0. And then 3 pi over 2 is straight down so we have a negative 1 y value. 2 pi is back to my start with a y value of 0. Then we keep going around a second time around the unit circle. 5 pi over 2 is again straight up. One full time around plus a quarter of a circle. So it has a y value of 1. 3 pi is straight left with a y value of 0. 7 pi over 2 is straight down. And then I'm back at 4 pi. And remember, it's a wave action, so we connect it with a smooth graph, smooth curve. And now that is 2 full periods of sine of x. A key thing to note here is that if I pick 2 points, right? If I pick this point and then the corresponding point on the next period, which is right there, the distance between these 2 points is 2 pi. And that's true for any 2 points that are 1 period apart. This point and this point are 2 pi away. That'll come into play next in just a little bit when we talk about multiple answers. So let's do cosine of x now. Again, remember, on my unit circle, cosine of x is the x value. Now I'm going to use the same key points. Take my full period, so 2 pi, and divide it by 4. So my key points are still pi over 2 away from each other. I always start at 0. And my key points are going to be pi over 2, pi, 3 pi over 2, and then 2 pi. And then again, one more time. 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So at 0, what's my x value here? My x value at 0 is 1. It's 1 over. So I start at 1. And I'll use a different color just to illustrate. I start at 1. Pi over 2 is straight up. Well, what is the x value there? Well, that's 0. The x value at pi, so on the other side of the circle, is negative 1. 3 pi over 2 is straight down with an x value of 0. And then 2 pi is right back where I started with an x value of 1. Then we go another time around the unit circle. 5 pi over 2 is straight up, so 0. 3 pi is straight to the left with an x value of negative 1. 7 pi over 2 is straight down. And then 4 pi is back where I started. Again, I'm going to connect these with a smooth curve. And you notice the same thing that I noticed with sine of x. If I were to pick 2 points that correspond that are 1 period away from each other, so I could pick right there and right there, they are 2 pi, a distance of 2 pi away from each other. So let's use our graphs that we just made in the previous slide to answer some of these questions. Remember, I'm on 0 to 4 pi. That's my interval. That's going to become very important. So we're going to reference these graphs we just made. So we want to find where sine of x is 1/2. Well, what we're going to do is we're going to go back to our graphs. And we're on the sine of x curve. And I'm going to draw out 1/2. And I'm going to make a horizontal line that intersects my sine of x curve. Notice my horizontal line crosses my sine of x curve 4 times. So I'm going to have 4 answers. If I had only been on 1 period, so 0 to 2 pi, I would have only crossed twice. So we have to be very careful about how many answers we're going to have based on what my period, how many periods I'm drawing. So we have 4 answers. So we want to know what value of x, what radian measure gives me a sine value of 1/2. Well, you can think back to your special triangles, and you might notice, oh, well, I know that a 30, 60, 90 triangle has side lengths 1, 2, square root of 3. And so, the sine of 30 gives you 1/2, 1 over 2. Remember, we're in radians now. We're in 0 to 4 pi, so we need radians. So I would know that my first answer in between 0 and pi over 2 would be pi over 6, 30 degrees. And I know my other answer, wrong way, my other answer is in between pi over 2 and pi. So I would get an answer of 5 pi over 6. And those are 2 of my answers, right? But we need 4 of them. I need to figure out what this one is and what this one is. Remember what I said earlier, though, if I pick 2 points that are 1 period away from each other, and you'll notice that this point here and this point here are 1 period away from each other, the distance between them is pi over 2. So I can just add pi over 2 pi, to this pi over 6. Well, pi over 2 pi is 12 pi over 6, so I get 13. Oh, that's kind of a bad 3. 13 pi over 6. Again, add 12 pi over 6 to my 5 pi over 6, and I get 17 pi over 6. And these are my 4 answers. Those are the 4 x values that cross my 1/2 line. Okay, now what about cosine of x is negative root 2 over 2? Well, again, I'm going to make a negative root 2 over 2 on my cosine graph. And you'll notice again that I cross my cosine graph 4 times. So I'm going to have 4 answers. Now you might think back to your special triangles and think, oh, if I draw my 45, 45, 90 triangle, I know that I have sides 1, 1, square root 2. And the cosine of 45 now, the cosine of pi over 4 gives me positive root 2 over 2. So my reference angle is pi over 4. Well, you'll notice my first point is in between pi over 2 and pi. So I'm a pi over 4 above pi over 2, which would give me 3 pi over 4. That's one of my answers. Well, the second one you'll notice is in between pi and 3 pi over 2. So it's a pi over 4 more than pi, which gives me 5 pi over 4. Now you'll notice again that, keep going the wrong way there, that you'll notice again that this point here and this point, my third point, are 1 period away from each other, or 2 pi. So what I can do is I can add 2 pi, or 8 pi over 4, to my 3 pi over 4. I add 8 pi to the top, and I get, what was that, 11 pi over 4? That's my third answer. Again, I would add 2 pi, or 8 pi over 4, to 5 pi over 4, and I get 13 pi over 4. And those are my 4 answers. And the last one, cosecant of x equals 1. Well, I haven't graphed cosecant of x yet, but I do know that cosecant is 1 over sine. So I can flip both sides. So I can think of this as cosecant over 1, 1 over 1. So I get sine of x is, well, 1 over 1 flipped is 1 over 1, or 1. So what I can find is where the sine of x is equal to 1. Well, if I come back to my sine graph, I notice that sine of x is only 1 at 2 places. And there are 2 key points, pi over 2 and 5 pi over 2. So my 2 answers here are pi over 2 and 5 pi over 2. I knew that there were only 2 answers because of my graph. So this is why graphing them can be very handy for actually solving answers. So let's kind of change gears a little bit to graphs of tangent and cotangent. So if you want to whip out your calculators again and graph y equals the tangent of x, make sure you're in radians again, click zoom trig, you're going to get something that looks a heck of a lot like this. Kind of a disco function, as I like to call it. And the question that would be asked, like we asked earlier, is what kind of a function is it? What does it resemble? Well, a disco in my mind. But what you can think is it periodic, right? Sine and cosine were periodic. This isn't a wave action, but is it periodic? And it is. After a certain point, it starts to repeat. So yes, it is periodic. You'll notice that if I follow one of these disco curves, right afterwards it drops back down, it follows an asymptote, and it starts doing it again. Well, what's the period here? Well, we'll discuss this more in just a second. Instead of 2 pi like sine and cosine, the period here is actually pi. And we'll discuss why in just a little bit. So let's try graphing it. Tangent first. Let's graph tangent. So again, I'm going to look at my unit circle, and we're going to do this one a little quicker because we can graph my key points now. Remember, my period here is pi. So what I'm going to do is I'm going to graph 4 key points again. So I'm going to take my period pi and divide by 4. So I'm going to, at each pi over 4, my key points are going to be pi over 4 apart. Starting at 0, my first key point is going to be pi over 4. My second key point is pi over 2. My third key point is 3 pi over 2. No, 3 pi over 4, sorry. Very different numbers. And then at pi. That's 1 full period to the right. And I can do the same thing backwards. I can go negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. So let's think about what happens to tangent. Remember, tangent is y over x. So at 0, I have a y value of 0, x value of 1, so I'm at 0. Let's use a different color here. What about at pi over 4? Well, pi over 4, we know that the y value is 1, the x value is 1. You can think about your special triangles for that. So I have a y value, a value of 1 here. What about pi over 2? Pi over 2, the y value is 1 divided by an x value of 0, which is undefined. There's actually what we call an asymptote here. 3 pi over 4, we know, is right here, right on the unit circle there. My y value there is a positive 1. My x value is a negative 1. So I'm going to be at a negative 1 here. And again at pi, which is right here, I have a y value of 0 over... Oh, sorry, a y value of 0, yep, over an x value of negative 1. So I'm back at 0 again. Then we can go in the opposite direction. A negative pi over 4 gives me, right here, is a y value of negative 1 over 1. And we notice negative pi over 2 is straight down, which gives me an asymptote again. And we can keep doing that over and over again. We're going to get a graph that looks something like this. And it repeats itself. You'll notice we have another asymptote over here at 5 pi over 4. But you kind of get the idea. Follows it over here as well, blah-de-blah. And we'll go a little bit more into in depth of this in class. Well, what's the period here? We said the period is pi. And the vertical stretch, well, the vertical stretch just means how big is it being stretched by. And we see the vertical stretch here, we're not, it's standard as just 1 again. So vertical stretch is just 1. And we'll talk about that later tomorrow in the next lecture. But what about cotangent of x? Well, if we go back to the unit circle, we're going to, again, make our key points at pi over 4 distance away from each other. Starting at 0, we're going to have pi over 4, and then pi over 2, and then 3 pi over 4, and then at pi again. And then the same thing in the negative direction. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. Well, cotangent, remember, is tangent flipped. So we have x over y values here. Change colors again. So we're going to come back to our unit circle. Oh, that might be a little hard to see with my purple on purple here. I'll make it a little farther over. Well, at 0, my x value is 1 divided by my y value of 0. So I actually start at 0 with an asymptote. It's undefined there. Well, let's talk about pi over 2. Pi over 2 is straight up. Let's grab a different color here. Pi over 2 is straight up, which gives me a y value of 1 and an x value of 0. So at pi over 2, I'm at 0. What about at pi? Pi is straight to the left, which would give me an x value of -1 over y of 0. So at pi, I have another asymptote. So you might be thinking, oh, this looks a heck of a lot like tangent. However, it's going to be slightly different, and you'll see why in just a second. What do you see at pi over 4? Well, using my special triangles, the x value is 1, and the y value is 1. So I'm actually going to be at 1 there. What about at 3 pi over 4? X value of -1 over y value 1, so I'm at -1 there. So it's slightly different in the fact that it starts high and then it goes low, whereas tangent went the opposite way. It started low and went high. And you'll notice the same things on the opposite side. And again, we can talk about more about this in class, but the important thing to know is that you still have asymptotes. It's a period of pi with a vertical stretch of 1. However, the difference is that cotangent starts high and goes low. So let's talk about extending the graph of cosine from -4 to 4. So instead of starting at 0 to 4 pi, we're going to start from -4 pi to 4 pi. So remember, this is 2 pi. 2 pi is a standard period of cosine, so we're having 2 periods either way, so a total of 4 periods. So again, to figure out what my key point, how far my key points are away from each other, we take the period 2 pi divided by 4 key points. So my key points are 2 pi away, pi over 2 away from each other. Always start at 0, x equals 0. So I have 1, 2, 3, 4, 6, 7, 8. I'm going to need 8 key points on either side because I have two periods total. So pi over 2, pi, 3 pi over 2, and then 2 pi. And then we keep going. 5 pi over 2, 3 pi, 7 pi over 2, and then 4 pi, or 8 pi over 2. So we'll start with the positive direction. Right? We know that if we look at our unit circle, cosine starts at an x value of 1. So I'm all the way up at 1, we go down to -1. So my first point is at 0, 1. Well, what am I at pi over 2? Pi over 2 is straight up with an x value of 0. Pi, straight left, so I have an x value of -1. And you can see the trend here. We're straight down, so we have an x value of 0 again, and then 2 pi is right where I started. And we keep going. 5 pi over 2 straight up, x value of 0. 3 pi is -1. 7 pi over 2 is straight down, or an x value of 0. And then 4 pi is back up at 1. So I can connect with a smooth curve. It's going to be a little squished because I made my key points pretty close together. There's one period. But you kind of get the picture, right? It starts to repeat. Now it's important to know on the negative side it's just going to be a mirror image, and we can put out make all the points again. So you're going to have 8 increments. 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. Got some allergies today apparently. Alright, my key points are going to be, again, pi over 2 away from each other. So negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. And then you keep going. Negative 5 pi over 2, negative 3 pi, negative 7 pi over 2, and a negative 4 pi. So if we think negative pi over 2, well, that's just straight down. The x value there is 0, just like we had before. Negative pi is straight left, so a -1. A negative 3 pi over 2 is straight up, or an x value of 0, and then negative 2 pi is right where I started, so an x value of 1. And then we repeat it. Straight down for negative 5 pi over 2, negative 3 pi is -1, negative 7 pi over 2, and then 4 pi is right back where I started. So we can connect the dots again using my wave. And you'll notice the left hand and the right side, the left side and the right side are just mirror images of each other. So how many periods do we have again? Well, each period is 2 pi, so we know we have 4 total periods because it goes from negative 4 pi to 4 pi. So let's graph secant of x. Remember, in order to graph secant of x, we're first going to graph its reciprocal, or cosine. Now, we've done cosine plenty of times now, where we know that it goes from positive 1 up there. Positive 1 to negative 1. We start at 1, and then we're going to have my 4 key points here. So pi over 2, pi, 3 pi over 2, and then 2 pi. Right at 0, we start at 1. 2 pi straight up, so we have a cosine of 0. Negative 1, 4 pi, back to 0, and then back where we started at 1. I'm going to make this with a dotted line. So what we're going to do is we're going to take each of these points, and just like secant and cosecant are reciprocals, we're just going to take the reciprocal of each of these y values. So let's think about 1, right? The cosine of 1, the cosine of 0 is, well, we can think of it as 1 over 1, right? So if we reciprocate this, taking the secant of 0, we flip the right-hand side, I still have 1 over 1. So secant and cosine both share this point of 1. And you'll notice the exact same thing for 2 pi. They both share that point of 1. Because we flip both sides, the cosine of 2 pi is 1. The secant of 2 pi is also 1. Because we flip 1 over 1, we get 1. But what about at pi over 2? The cosine of pi over 2 gives me 0, right? The cosine of pi over 2 gives me 0. We can think of it as 0 over 1. So the secant of pi over 2 will give me 1 over 0, or undefined. So we actually have asymptotes. And you'll notice the same thing for 3 pi over 2. We flip both sides, we get a 1 over 0. So we have asymptotes there. Well, if we think about pi then, the cosine of pi is negative 1, so the secant of pi would be a negative 1 over 1, so we also share that negative 1 point. But let's think about a point in between 0 and pi over 2. So how about half there? The point right there at a half. Well, we would flip the left-hand side, so we get the cosine of this x value, which is about 60 degrees, which is a pi over 3. But we'd flip the right-hand side, so it would be 2 over 1. So we're actually up here at 2. And it turns out that my secant graph looks kind of like parabolas, where it shares the 1 and negative 1 points, but instead of going down, it goes up. So you'll notice while the graph of cosine is always in between negative 1 and 1, the graph of secant is never in between there. It's always 1 or above, or negative 1 and below. So that's how we graph the reciprocal trig functions. Start with the parent graph, so in this case cosine, and then from there graph secant. So go ahead and write your summary and any questions you have. Bring it to class tomorrow, and then the assignment here, try to get some of them done. It takes time. We'll have plenty of time in class to look at these, but go ahead and give them a go.